Okay, at this stage, we're going to start using ln more, partly because the formulas that we've got, this p e to the kt and stuff, they come from calculus, and calculus needs natural logarithms. Don't even ask. So I'll just recall. I'm going to use capital L's, even though it's technically, they like to use little l's, because it looks like in if you use a little l. ln x is log base e of x. Okay, where e is this weird number a little less than 3, the way that pi is a little more than 3. Okay. Again, before taking the ln, you need to scrape off anything that's not e. So add 15 first. You un-e by lning the other side. That's another way to think about it. Lovely. You un-ln by e-ing the other side, exponentiating. Okay. Yeah, we can turn them into decimals, but I don't really care. So. We're ready to un-ln, or un-e by ln. Okay. Okay, so we're going to use A equals P. I call this the pocket formula. Yeah. R is used instead of K, and then it's called the PERT formula. Yeah, whatever. Okay, half-life means current amount is half of the initial. Also notice initial means at time 0. And if you plug in 0 for t, you just get p times 1. So the initial amount is just the amount p. So we'll just, instead of a, we'll use half of the initial amount. Don't mess with p on the right side of the equal sign. And it says the time is 5,700 years. So I'm going to solve for k. First, we can cancel the p's. And then I can take the ln un-e by ln on the other side. And then k as a ratio is ln of a half over 5,700. Okay, how much time is there until there's about 12% left? So a is going to be 0.12 times the original. Now, what's k? K is the same k. I'm just going to instead of trying to write that horrible fraction into the exponent, I don't know. So to solve for t, I'm going to flip the fraction to the other side. So ln 0.12 gets ended up multiplied by 5,700 and divided by ln 0.5. Calculator says about 17,000 years. Incidentally, all the extra decimals, pretty much garbage in this case, because 5,700 years is only an approximation, and it isn't really completely constant because of sunspots, but, whatever. We're splitting up, first split up the multiplication into addition. Then pop exponents. How would I go backwards? I would unpop the exponents first. Division splits into subtraction. And the exponent for the x to the 1/2 x to the 1/2 is square root x. Speaking of which, cube root is 1/3. This one, the exponent is the main operation. So I could just go 1/3 of the whole thing. And then continue to pop. Or I could have distributed the exponent first and made it x to the 2/3 and y to the 5/3. Either way, okay, unpop the exponents. How do we do this? 2 is ln of e squared. Okay, one big honk in ln. Do not divide two ln's unless you really mean the change of base formula. The division is inside.
Not
X squared y, e squared y over z. No addition or subtraction should be inside. Okay. -1 is ln of e to the -1. let's see. E to the negative 1 is E on the bottom. And x to the 2/3 is cube root and square.